Mark Zuckerberg recently stated that AI agent development is moving slower than expected. The engineering reality tells a different story. These agents are not slow, they are physically unstable. The bottleneck isn't silicon thinking speed, but mechanical latency and actuator precision required to interact with a chaotic physical world. We often see digital intelligence fail spectacularly at simple tasks like folding laundry or walking on uneven terrain. This gap between what software can do instantly and what machines can actually endure is the core of the problem today. The common assumption is that if we simply make the models larger, they will solve everything. However, recent research from late 2025 confirms a fundamental disconnect known as spatial intelligence failure. While large language models have revolutionized symbolic reasoning, they lack an understanding of metric geometry and physical physics. Agents frequently hallucinate paths through solid walls or suggest physically impossible grasps because the model understands text but not the three-dimensional reality it is trying to navigate. This creates a scenario where a robot might plan a movement that would require passing through a wall just to reach its target, simply because the software treats space as abstract data rather than physical resistance. This failure points directly to an architectural flaw in how we build these systems today. We are seeing what researchers call the data geography paradox. Cloud-centric designs are failing physical agents because critical local context is lost or degraded when sent over a network. Transient operating system states, real-time sensor streams, and dark matter data such as local file hierarchies are cut off from ground truth context during transit. When an agent relies on the cloud for decision-making in dynamic settings, it introduces fatal delays that prevent cognitive alignment with its environment. The result is a system that thinks too slowly to react fast enough to keep itself upright or safe. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The most striking evidence of this problem comes from behavioral studies involving over 1,300 participants who were asked to trust AI predictions versus random framing. When participants trusted the AI, their odds of foregoing guaranteed rewards increased by a factor of 3.39 compared to those receiving random information. Yet, despite this high level of trust in digital outputs, earnings reductions ranging between 10.7 and 42% were observed among those influenced by these predictions. This statistic highlights a dangerous disconnect. We are building systems that people blindly follow because they appear authoritative, even when the physical execution is fundamentally flawed or unreliable. To solve this, engineers must stop treating the robot body as an afterthought. The solution lies in rebuilding what researchers term the physical AI harness. Benchmarks show that reconstructing just this middleware layer can improve task reliability by an order of magnitude without changing the underlying brain model at all. This proves that the limitation is not intelligence, but the nervous system connecting thought to action. Current robot middleware is often hand-built and insufficient for complex tasks. We need standardized layers that manage control trajectories, computing schedules, and communication bandwidth simultaneously, because learned policies cross all three domains instantly in a physical environment. This shift represents a move away from what some call premature ossification. Embedding rapidly evolving AI into long-lived physical infrastructure creates a risk where hardware becomes obsolete before software can adapt. This is the core architectural failure preventing deployment in safety-critical domains like disaster response and healthcare, distinct from simple IoT telemetry reporting. A robot designed for 5 years of operation cannot rely on cloud updates that change every month without breaking its mechanical constraints. The binding constraint on agent behavior has shifted from the model itself to the layer governing it. We are moving toward a prefactual turn where edge computing keeps decision-making local to avoid latency-induced crashes in the real world. The visual metaphor for our current state is like having a Formula One car with an engine that revs infinitely fast but no suspension and tires made of glass. The software is ready, capable of processing complex instructions instantly, but the physical interface required to harness that power is missing. We are trying to plug a super-fast digital brain into slow, rigid mechanical bodies without the right interface layer. The slowness Zuckerberg mentions is actually the time it takes for these systems to learn how to exist in physics. It requires new engineering standards rather than just bigger models or faster chips. We must recognize that scaling laws are hitting a wall when applied blindly to physical agents. Simply throwing more compute at the problem does not solve the issue of mechanical latency or actuator precision gaps. The priority now is framework-level task decomposition and edge computing architectures that allow for safe reversion, known as transfer fallbacks, when physical predictions go wrong. This ensures that if an agent misjudges a grip strength or walking surface, it can immediately abort without catastrophic failure rather than waiting for software updates to fix the logic error later. The future of robotics depends on this shift from pure scaling to harness engineering. We need systems where the brain and body are co-designed with standardized protocols for projection gates, isolation bounds, and transfer fallbacks. Only then will we see agents that can operate reliably in the chaotic real world rather than failing at simple tasks because they do not understand the physics of their own existence. The path forward is clear. Build a nervous system fast enough to match the brain it serves. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.